Now, China has postponed an ambitious lunar exploration mission to scour the moon's south pole.
So the Chang'e-7 mission is designed to search the region for water ice. The uncrewed spacecraft was originally expected to lift off this week, but the China Manned Space Agency says the mission did not meet the launch conditions after a comprehensive assessment and cannot take place during the planned window this year. It's not clear how soon China will attempt to get the mission off the ground. Thailand's National Astronomical Research Institute, which developed a scientific instrument for the mission, said the postponement was linked to Tropical Storm Lara developing in the South China Sea.
Chang'e-7 is widely considered one of the most complex robotic space missions. Finding accessible water ice could be important for future lunar bases, providing water for astronauts and potentially helping produce oxygen and rocket fuel. The U.S., India, and Russia have also set their targets on the moon's south pole.
The delay comes less than 2 weeks after a rocket launch from China's Wenchang spaceport ran into trouble and exploded. China has invested heavily in its space program in recent years, the country aiming to land astronauts on the moon before 2030.
But for more on the mission and the race to the moon, let's speak now with Clive Neal, Professor of Civil and Environmental Engineering and Earth Sciences at the University of Notre Dame. Professor Neal, thank you very much for joining us. So this isn't simply a case of waiting a day or two for better weather, but China says Chang'e-7 can't launch within its planned window this year. What could be behind the delay?
Well, if you look at the readiness that is going to be needed for such a complex mission, there are many things that have to come together. And the very fact that you've got all these typhoons in the region as well, that is also going to put a dent in it. And getting to the South Pole is very complex because of the lighting conditions. The lighting conditions can change, and there could be certain times, and this is what happens with sending rovers to the South Pole, that when there's going to be darkness. So you miss the window, you can't just go in another couple of weeks because there's no sunlight anymore, and you have to wait for the same window coming up in the next year. So this is not a surprise. They are making sure that this complex mission is ready to go, and when they land, they have light in order to recharge the batteries in the lander and then the rover, and get the hopper to go into the dark places as well.
So, Prof. Neal, I just want to make sure I understand you correctly. So this is partly the weather, but also partly because of the sunlight-related issues that you mentioned. Won't these be, resolved or be in the correct place, if you like, in the September window?
Well, it depends exactly where they're going to go. And I'm sure they are looking at this in a lot of detail, because we've now got a very good picture of how the sunlight changes at the lunar South Pole with all the missions that have been going there, including Lunar Reconnaissance Orbiter. And they have given us great maps of sunlight that can be predictable way into the future now. So landing in darkness is not really the right thing to do. So they really need to get the light ready and go in the right time window so they can maximize the return from the big investment in this very complex mission.
Professor, and China has had an extraordinary run of lunar successes of late. And how much of a setback is this delay for China's lunar program?
This is not really a setback. It's just being cautious. Because if you look at the number of components involved, a very complex mission, you have an orbiter, you have a lander, and within that lander, you also have then a hopper, a sort of suborbital spacecraft that can go around the region, and then a rover that can explore the local region around the lander, and try to make sure that the optimal launch window is there so you can maximize the light so that the rover can go in and out of permanently shadowed regions and then come out and recharge the batteries to prolong the mission. You need to maximize those opportunities through those launch windows.
Okay, and so looking at what this mission was actually trying to achieve, we already have evidence of water ice near the lunar poles, but what could Chang'e-7 tell us that we don't already know?
Chang'e-7 will tell us that what we don't really know, we don't have ground truth. Well, we have one data point with the L-cross impact emission at the Cabeus crater of 5.6% water in the regolith. But we really don't have any ground truth. We've got a lot of orbital data that suggests there could be a lot of water ice there, but we need to get to the surface to just see how extensive those water ice deposits are in these various craters around the south pole of the moon. And that is something that has never been done. This is another first for China. As I say, I'm excited to see what the results are going to be perfectly honest with you.
Prof. Neil, if Chang'e-7 does confirm ground truth, as you put it, at its target site near the Shackleton crater, does that decide where China is probably going to plant its future lunar base, or are there lots more factors that have to be considered?
Well, it depends what they find. And if they do find extensive deposits of water ice, then obviously the right place to put their lunar base is close to those resources that can sustain humans on the surface of the moon. But that's not the end of the story. There are many other places where water ice could be present, and we need an international prospecting campaign, not just one mission, to be able to look at as many of these as we can with ground truth missions, so that we can get a more extensive picture of just how much is there. And the fact that you mentioned rocket fuel. There is going to have to be an awful lot of water ice there if we're going to start processing water to give hydrogen and oxygen rocket fuel, so that then we can refuel the different rockets that are going to the moon. So there's a lot of work still to be done, but this is the beginning, and it can be very, very exciting.
So if China or any other country finds commercially usable water there, I wonder who gets to use it?
Who gets to use it? Well, that's up to the person that finds it according to current law. Nobody can own any territory on the moon, but a number of countries, China not included, have passed legislation to say that they can use the resources that they get from those different areas. And this is where we get lawyers involved, and this is where things get discussed at the United Nations. And it's going to be fascinating, because these data that Chang'e-7 is going to collect are going to directly influence those discussions at the UN, who are actually actively looking at the legal aspects of these space resource activities right now.
Professor, Chang'e-7, we know, is carrying international science payloads, including, that Thai instrument. Given how this lunar conversation is being framed, and I think the media is guilty of this, as a China-US race, does foreign participation say something about China's own positioning as far as this race to the moon is concerned?
I don't like the term races, because history shows us that when you have a space race, you do not end up with an enduring a human space exploration program. If you look at Apollo, it was cancelled less than 4 years after Apollo 11 won that space race. So if we now look at the International Space Station, it's been over 20 years where we've had a continuous human presence in low Earth orbit, and that's done through international cooperation. So the fact that China is fostering international cooperation by allowing international instruments on their payloads, just as the US is a great way to sort of get that cooperative spirit moving. And we'll just see how far this cooperation can go.
Indeed. Okay, Professor Neil, thank you very much for your insight this morning. Clive Neil, Professor of Civil and Environmental Engineering and Earth Sciences at the University of Notre Dame.